All right, so in A, 9A, and B is 120. So we get out our calculator, which I do not have one in front of me, and I hate using the one on the computer. Garumph. Oh, there it is. Yo. What? Okay, so the altitude is 52.6, yes? So B, one oblique triangle. That means it's got to go way out here, yeah? That's the blue line. If there's going to be a blue line out there, that blue line has to be, B has to be greater than 52.6, but also what? Greater than 120, right? Not equal to, sorry, greater than. Everybody understands that, yes? To have one right triangle, that'll be the orange one. Then B equals 52.6. Two oblique triangles. That would be the purple one. That means it could go there or there. B is greater than 52.6, but B is less than 120. And finally, no triangles. That is when B is less than 52.6. Is everybody cool? Now, if I change this around and I say A is obtuse now, the opposite of 26, so let's say it's 154, and B is 120, right? B is 120. A's got to be over here now, yes? So what are the options for A? It's different, right? We don't need an altitude, do we? Because B, if B is less than 120, can it make a triangle? No. If B equals 120, can it make a triangle? B has to be greater than 120 if I have an obtuse, yes? That's the only way we get a triangle. B must be, this is angle A, A must be greater than B, because this is B. Everybody's cool with ambiguous triangles? And how does it happen in real life? When you do the calculations with your triangle and you do shift sign on this triangle here, it's going to tell you 26, isn't it? Right? Because 26, it deals in the first quadrant. It doesn't deal with this. So you have to be aware of what is actually happening. Does everybody follow me? That's why at the end, what's the last thing we do when we do a question? We check, is the biggest angle across from the biggest side. Everybody good? Once, twice, thrice? Okay. Now, my good friend Brittany asked specifically for 17 and 18, I believe she said. All right, so All right, let's read the question. So here is Armand, and he sees a cairn at the top of a hill that is 500 meters away. A cairn is a pile of rocks. Like an inukshuk is a kind of cairn, right? From this point, the group made a second stop at the bottom of the hill. So from this point, the cairn is 360 meters away. The angle between the cairn and Armand's first stop, this point, the angle between the cairn, Armand's first stop, and his second stop is 35. Yeah, I don't like the way that's worded. I gotta think about this. I need more space too. So during the group's first stop, so they're walking along and they stop, and they spot a cairn at the top of the hill. I would say that's where the 500 is. Yeah. And then here, 360. And the angle between the cairn, his first stop, and his second stop is 35. Okay, so the only way I could see that 35, he stopped on the other side of the hill to make that 35. That's the only way I can see that working. Which would mean Q equals 360 sine 35, which equals $206. But we've already got that. I don't like that question at all, because I can't wrap my head around it. I can do the trig, but I can't. During the group's first spot, he spotted the cairn at the top of a hill, a distance of 500 meters away. So maybe you put the 500 here. There's the cairn. And then here, it's 360. Or there is their Armand's first stop, Armand's second stop. And that's 360. The angle between the cairn. Cairn, Armand's first stop, and Armand's second stop is 35. There's your 35. Now I got it. I just don't like the way that's worded. There we go. And there is Armand's second stop. So it's either 500 or 360 there. Okay, and then, of course, it's what I just said. He could have walked all the way over here and had the 35 there. That's why it's 2. There we go. Yuck. Possible distances, it's either this distance right here or it's this distance right here. And you're either going to make the black triangle or the big red triangle. And 18, you said? Excuse me. The height of the antenna is 30 meters. Determine the height of the entire structure. Okay, so this little bit right here is 30, right? So I have this triangle, 30, 0.9 degrees, and 34.5, right? And I want the height of the entire structure. So, from 34.5, do I know this line right here? No, that's this line right here, yes? So, do I have a pair there? I got 0.9 right there and 30 there, yeah? So, sine 0.9 over 30 equals sine 34.5 over, let's call it m. Cool? Yeah. And then once you have that, this is just a 90-degree triangle, right? Yeah. You've got
about the first triangle, so I just did like the second triangle.
Okay. All right, everybody good?
Would you have to add the height of the antenna with the total structure?
Well, yeah, because it's total structure, right? Everybody good? Can we move it along? Okay, the next thing we do, actually I don't think I've printed it yet, is the cosine law. Now the cosine law is lovely because there is no ambiguity about it. The cosine law is just the cosine law. But that's not what I want. I want the cosine law. And I think the pages are going to be messed up right now, but I'm not 100% sure. What page is cosine law for you people? 250?
15.
15?
Yeah. Go home. No, I already saw. We did a thorough scan of this book. We knew. Yeah, you can have it down. No. We're halfway. No.
Now again, if you were in my pre-dip honors class, I was expecting you to go into IB, so I wasn't expecting you to have this. But you have seen these exact pages.
Is it not the textbook page?
No, not the textbook pages, just the notes.
Sorry to disappoint. Here we are.
Oh, son of a motherless goat.
No. Oh. Are you going to start season 2 today?
Season 2 of what? Oh, does that start today? Season 2 of you? Oh. Then why are you asking about it?
I was asking him.
Oh.
Yeah, you were.
I'm only on the second episode of the first season, so no spoilers. Shut up. It's bothersome for me because my best friend in the world is named Beck, but it's a guy. And it's his first name. But it's still tough to listen to him talk about Beck.
Yeah. It's tough to see what happens.
Shut it! Beck's the super hot girl. The guy's pretty easy on the eyes, too, so. It's a good show so far. My daughter's watching, and I'm debating about maybe not letting her, but I can't decide. The dude was on James Corden a couple of nights ago. And he said some stuff, and my daughter's like, I didn't know that. I had to stop watching.
And even if you watch like,
But we didn't want to stop watching, because who doesn't love James Corden?
the season 2 trailer, like it's kind of spoils season 1, but also
I don't watch trailers, so it's okay. All right. So, ladies and gentlemen, let us get back to business. Up here in this top corner, draw a triangle. Put some number here. That number has to be greater than what? Excellent. Let's say that's 105. Let's say that's 37. And let's say that's 35. Could you figure everything out of that triangle? Why? Because you've got an angle and a side and one other piece of information, yes? Right? What if I took away the 35 and I put, I told you this side was 21. Could you still solve it? Why? Because I still got this pair, yeah? As long as I can make a pair for the sine law and I have one other piece of information, I'm in good shape, right? Now, some kids will say, okay, so if I have one angle and two sides, I can do it, right? Right? Could you do that one? It's one angle and two sides. Could you do that one? No, of course not. So we need another rule that will work for us. And that is the cosine law, or shortened, and I apologize because you've heard the joke already, to coslaw. I hate coslaw. Get it? Okay. But I really do hate coleslaw. I can't stand the stuff. I don't know what the hell, right? It's so gross. I don't get it. People go to White Spot. My grandma, or my wife's grandma, used to go to White Spot and take everybody else's coleslaw. But she is crazy. She'd take the kale leaf off of everybody's plate, too, and take it home. She loved the kale. She was Dutch. I don't know. All right, so we're all good? We need another rule. This is it right here. Please notice it's got all the same stuff as the sine law, yeah? And please also notice it looks a lot like Pythagoras, right? Okay. So, this is what we use when we have that, which is called side, angle, side. When you have a side sandwiching an angle, we use this. Okay? Now, you're intelligent young people. Oops, one sec. What will this find me right now? A side or an angle? A side. How do you know it's going to find me a side? Because it's a small c, right? Now, you'll also notice that will it find me the side or will it find me the square of the side? So what do you got to do at the end? Square root. Now, this gets weird. There's a way to do this. The smartest way to do this is to make C the side you seek. All right? No matter however the triangle is labeled, if you are looking for a side, you make it C. So look at my example here. What's the only side we don't know? Not a hypotenuse. Right? The longest side, right? So we would make this little c, even if this was labeled as big A. Okay? Actually, I'll label that in red, because red is the triangle we're working with. Even though that's big A, we're going to label this little c, because that's the side I seek. Everybody understand? Which would make this side little b, this side little a. And this would be big C. Black is the way we would work it. Does everybody understand? No matter how it's labeled, you make what you seek C. Everybody cool? So it's real easy for this. There's only one thing to remember. We must square root our answer. Or vans, which, in case you didn't know, is where the symbol comes from. It is square root of answer. Math. Hello. All done? Okay. Now, of course, sometimes, let's say we know this side is 42 and we don't know that. Can I do sine law? No, because I don't know any angles, right? But cos law, as it's written, doesn't help me, does it? So what I've got to do is I have to use, if I need a side, I need big C isolated. And how do we isolate it? Algebra. So I've got C squared equals A squared plus B squared minus 2AB cos C. I need to get that C isolated. Oh, shut up. If I need an angle. Thank you. Just did that. So what's got to move? Do algebra with me. What's got to move? A squared and B squared. What are they right now? Positive or negative? So I'm going to get C squared minus A squared minus B squared. Now, this is where every kid screws up. What math is happening there? Multiply, multiply, multiply. Every kid sees that negative and wants to bring it over here and make it positive. No. If I had this, negative 2x equaled 14, what would you do? You divide by negative 2. So here I have negative 2 times times. So what do I got to do? Divide by negative 2ab, and that will get me cos C. Now, what do I got to remember at the end of this one? I got to shift cos at the end. Everybody cool? Now, here is a nice little summary of everything. I didn't even make you write it down. Good? Now, obviously, just like with sine law, we start with pretend fake triangles on a piece of paper, yes? But they have real-world applications. We'll apply them to real-world situations in a moment. But first, we'll make sure that we can do this with fake triangles on a piece of paper. How are we going to start this bad boy? I got to draw a triangle, yeah? Where do you want to start? The angle, the sides, what do you want to draw first? I don't really care. Sides? Okay. I got a 20 centimeter side, which goes from A to C, yeah? Right? And I got an 11 centimeter side that goes from B to C, yeah? So A to C, B to C, this must be C, yes? So that makes that A, that makes that B. And angle, see the little angle symbol there? ACB equals 20 degrees. I can't do sine law. I have to use cos law. And it's labeled perfectly for us because it's our first one, right? What?
Oh, wait, never mind.
Okay. So, what is this side right here? Lil C. This one's labeled perfectly because it's the first one we're going to try. Again, this isn't difficult, but it can be a bit of a pain to get on your calculator, okay? So, show it. C squared equals 20 squared, let's do it in proper order. 11 squared plus 20 squared minus 2 times 20 times 11 times cos 20. Right? Now listen to me. if you're not super hot with your calculator, then you should do this in stages. But let's see if you're super hot with your calculator. Everybody try to punch this in, all right? And when I say punch this in, I want the value for C at the end, including the square root. So everybody try. And just one decimal place is fine. I don't like the coastlaw. Because it's hard to punch in your calculator. All right, who has some answers for me? I hear 10.4. What else? Pardon me? I got an 8.7. What else? I was able, on purpose, I was able to make my calculator show me 17.8. Would I write that down? Probably not, because 20 is probably the smallest side, yeah? Smallest angle. So I hear a 10.4, I hear an 8.7, and I was able to make 17.7, and nobody else bothered to try? What did you get, 10.4? 10.4? Okay. Now, does that make sense? It could. What's the only way to prove it? Now that I know this is 10.4, what's the only way to prove it? I would have to check it with the sine law, yeah? Everybody cool? How would I check that with the sine law? Now, once we practice this a bit, would we ever check the sine law? Once we know we're doing it right? We're probably okay. But we're going to check with the sine law here, yeah? So it would be sine 20 over 10.4 would have to equal what? Sine B over 20 and sine A over 11, right? Takes 2 seconds to check. 20 sine 20 divided by 10 point. So when I do that, I get this to be 41, which makes this what? Automatically, do I need to go on? Yep. So when I check with sine law, I get 41 there, which gets me what here? What? 119. Is that possible? What is this just proven? What must this one be? It's not 41. Because this has to be the biggest angle, yes? So what is it? What has the same sign as 41? 139. 139, right? Which makes this what? Makes this 21, right? Now, does that make sense? These are almost the same angle, which means these sides must be almost the same because it's an isosceles triangle. Does everybody follow me? That's the problem with sine law. Right? That's why we check. But we did it right. Is everybody cool? Go once. Go twice. Go thrice.
How do we know which angles have the same sign as other angles?
That's the whole beginning of the unit. McKenna. Cast.
Oh, okay. Oh, yeah, I remember.
Okay. It's the reference angle, right? Okay. All right, turn the page over. What's different? What's different? It's not the same letters, so we got to be careful. So we'll draw it with PQR in black. So RP is 7. Oops. Seven. RQ is 8, and PQ is 10. Calculate the measure of angle Q. Q is the angle we seek, yes? So how should we relabel this? We make Q big C, which makes 7 what? Little c. Do the other two matter? Big A, big B, little a, little b. Now, since I seek an angle, I have to use the rearranged cos law, yes? Which is cos C equals C squared minus A squared minus B squared over negative 2AB. And then we just fill it in. 7 squared minus 8 squared minus 10 squared over negative 2 times 8 times 10. And then, what do I have to do? I gotta shift coset. Now listen to me. This is a real bear to try and punch into your calculator all at once. Give it a shot, see if you can do it. I recommend getting this decimal first and then shift cos. But it's up to you. Who has an answer for me? Pardon me, Crystal? I have a 44. Do I have any corroboration of 44? Yes. Does 44 make sense? Well, let's think for a second. If that's 44, 8 and 7 are almost the same, yeah? Right? Which would mean this would be what? Around 44, agreed? So 44, which means this would have to be around 90, agreed? Which means that's pretty close to a right angle triangle, agreed? What's 8 squared? What's 7 squared? What's 64 and 49? 113, right? What's square root of 113? Just a little more than 10, right? So did we do it right? Right. Picking up what I'm putting down? Now, do you see how all your knowledge helps here? Yes, we can punch it into our calculator, but everyone was a little bit nervous, yes? To say it out loud, right? But you remember, okay, well, I know about isosceles triangles. I know about 45, 45, 90. I know about hypotenuses, right? Bring everything to the party. Okay? Now, let's look at this next question, which is a real-life type of question. This is the type of stuff that anybody using radar has to be able to do quickly and effectively, because radar can fail. Now, those of you that have been in my class before have heard this joke. A great many times my students read that as 34,450 kilometers east of something. So apparently the WestJet flight is flying well into space. Of course it is, right? What is it really? Flight 344 is 40 kilometers east. 50. Okay? So, here's the... Now, remember, I told you we are going to be transitioning into real life stuff, yes? So I'm going to quickly remind you of something. We know that as X and Y, yes? But it's also what? North, east, south, west. Never eat shredded wheat. Never eat soggy wieners. Whatever. Never enter Santa's workshop. I haven't heard that one. All right, everybody with me? Now this is where it gets weird. When we count angles in math class, where do we start? Don't look at the NEWS. Where do we start if we're counting an angle in math class? Where is 0? Well, no, an angle can't go from just the middle. In math class, when we're measuring an angle, where do we start? The positive x-axis. So this is 0, isn't it? In real life, it's not. In real life, this is 0. Okay? And we count this way. So this should be a reminder for almost all of you. If I tell you I am walking at a heading of 80 degrees, where am I walking? In which quadrant? Quadrant 1. Almost straight east, because east is 90. So that would be 80 degrees. Everybody remembers this? Okay, that is 80 degrees. What if I told you I was walking at 205? Where would I be walking? Third quadrant. I'll be walking right down here because that's 180. So this is 205. Everybody remembers this? Some of you may not. Everybody cool? Ish? Cool enough? Right? Now, here's where it gets weird. Can I do trig on these? Kind of, because this is 180, this is 205, so what's this right in here? No, that's not a reference angle. What is this number right in here? That's 205. So what's this? 25, because it's 180 to here. Right? If that's 25, what's this? Somebody already said it. 65. Everybody cool? Good, that's half of what you need to know, because there's another way we write directions. The other way we write directions is this. North, 42 east. North is the direction you start. This is your adjustment, and this is the adjustment direction. So, north 42 east, if I made no adjustment, I'd go straight up here, yes? But I'm going to adjust 42 degrees to the east. So I'd be over here. This is the 42. What makes this confusing? It's exactly the same as east 48 north. Because if this is 42, this is 48. Everybody cool?
So the angle is the number, not the length of the line.
No, it's got nothing to do with the length of the line. The angle is the adjustment away from the first letter towards the second letter. Everybody cool? We'll go over it again in a bit. So, the air traffic controller finds WestJet 344, 50 kilometers east of the tower. So let's put the tower right there. The jet is right here. There's flight 344. I'm going to underline him in, we'll just call him flight 344. 50K. At the same time, Jazz Flight 712 is 25 kilometers from the tower. No direction, yeah? So I'm just going to write down here, we're going to put J712. This is 25. The angle between them is 20 degrees. I need to know how far apart they are so they don't crash. Is this C squared or cos C? C squared. That red line is what? What I seek. So what do I make it? Little c, which makes this what? Big C, and now I just solve it. Everybody cool? Yeah? So I'd write it out. C squared. Well, I'm good enough with my calculator now. I'm going to go C equals the square root of 25 squared plus 50 squared minus 2 times 25 times 50 times cos 20. And get my answer. And you're going to punch that in while I punch it in, and you're going to get an answer. What do we get? 1 decimal place is fine. What? 27.8? Well, 27.85, so I would say 27.9. Again, don't make me do a rounding lesson, but every time somebody says a number, I feel like I need to do a lesson in how to round. Do I need to do a lesson in how to round? Do I? Then start saying the right numbers. Or I'll do like grade 3. I'll get you up here and I'll do a whole big physical demonstration about how to round. See if you can figure out number 4. Draw the sketch first. I'm going to give you a hint. There is misinformation in there. There's information there that you think might be important, but isn't. See if you can filter it out. Do not try to do the cosine stuff until you have the triangle drawn. Would anybody like to describe, or better yet, draw the triangle on my screen? Yes, Preston. Go, Preston. It's your birthday.
It's my birthday.
He's actually doing a Prezi. Get it?
Oh dear.
This captain must have been a little drunk, eh?
Just a little.
He's getting into the Navy rum.
Too many drinks for him.
Is that acceptable? Meaning that's the harbor, right? Because that's where they started from, yeah? I want the angle they left. So I need this angle right here, right? And he was smart enough to call it capital C. Yeah? Ladies and gentlemen, I have a question. Every time one of you comes up here, you draw your triangles way bigger than I do. Have I been drawing triangles too small for the past 20 years? Should I draw them bigger? Are you sure? Because every time someone comes up, I say, draw it. It's huge.
I draw everything bigger than
It's fair enough. I'm not trying to put you down, Preston. I'm saying every one of you does that. And I would have drawn this like this big.
Well.
All right. So, nothing personal, Preston. I'm just going to shift it over a little here. All right. So, cos C would equal what? Ten squared minus 24 squared minus 13 squared. Does order matter? No, because 5 minus 2 minus 3 is the same as 5 minus 3 minus 2. Over negative 2 times what? 24 and 13, right? What's the problem here? What's that going to equal? It's going to equal more than 1, isn't it? Is cosine ever allowed to be more than 1? So is this a possible triangle? No, it's an impossible triangle. Why would I put it in here? I used to put it on a test with an answer D of it's impossible. And kids would sit there for 20 minutes doing one question, trying to make this work, even though I gave them the choice of saying it was impossible. I moved it off the test because too many kids got it wrong. Should I put it back on the test now? It's an impossible triangle, right? What needs to be a bigger number? They got to be further apart, yeah? Right? Because I need this number to be less than 624, yeah? Everybody cool? All right. Now, again, my grade 10s from last year, remember I'm very proud of this drawing. You probably remember how to do it as well. But, huh? It's drawn pretty accurately. Huh? Did I go straight line? Yes. I'm not going to tell you I free drew that tower. I stole it. So again, ladies and gentlemen, this is the type. Now, I've made it seem not very real life, right? By drawing the crumbling tower and the freaky birds and blah, 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 blah. But this is real life use of trig. This is what trig is for. It is to measure things that you cannot measure. All right? Now, I know that you've been in my class before. You've heard me give this example. You see the people standing out on the street looking through a telescope at somebody on the other side of the street who's holding up a metal pole, right? This is what they're doing. They're measuring distances for things like pipelines and stuff like that because they can't run a tape measure across the street because people get angry if their progress somewhere is stopped. That is what trig is for. It is for indirect measurement. Everybody cool? So let's do this question. We may need to do it together, but we may not. I seek height, yes? So I seek information about this yellow triangle. Agreed? Now, to do trig, no matter what I'm doing, either SOHCAHTOA trig, cosine law, or sine law, I need at least how many pieces of information? 2. In that yellow triangle, do I have 2 pieces of information? I do not. So I am forced to use this purple triangle where I can get information, can't I? Now, I have 2 pieces of information about the purple triangle, don't I? And if it was a SOHCAHTOA triangle, 2 is enough, isn't it? Because you have an angle and a side. But is this a SOHCAHTOA triangle? No, it's a cosine law or sine law triangle. Which one can I do? Sine or cosine law? Henry? Of course it's the sine law. Why?
Because the thing's like 180 degrees.
Right. What's this?
149.
149. 18, so what's this? 13. There's your pair, 13 and 20, yes? Once you have 13 and 20, you can get 18 and this side, yes? And isn't that the yellow side which I need? Picking up what I'm putting down? People get paid a lot of money to do this in real life. Look through a telescope and then do grade 10 and 11 trig. Now, they'll all tell you that it's way harder than that. Of course it is. There's a lot more to it. But the actual work that they do is grade 11 trig. Everybody cool? All right. Now listen. You're going to find that answer. I'm going to be talking for a moment. I kept the textbook page that had everything for you. I cannot stress this enough, ladies and gentlemen. I used to teach all versions of it, like rotated around, and kids kept screwing it up. So I changed to saying, just make what you seek see. All right? But here it all is in one spot if you want that. You're going to work on page 220. Oh, for you it's 218, right? Right? You're going to do 218, 219. You're going to work. There's a lot of it. You don't have to do it all. Do a few word problems from each one. Listen to me closely. If you think you're really ready to go, make sure you can do the extends. Now, obviously, I haven't been given answers, so you would just be attempting the extends, yes? Tomorrow, we will go over this, and you will do an assignment on sine law and cos law. What? Oh, you guys have the buyout tomorrow. All right, so that's your homework. Friday, we'll be marking it. Okay? Everybody good? All right, now remember, I don't care how much of this you do, but you better be able to at least attempt figuring out 23 through 26. Like have a triangle drawn for it, okay? Because you're not going to know the right answer because I forgot to put them in from this unit. All right? Everybody understand? Let's finish this guy up. What am I doing in purple? (13 over sine 20 equals what? 18 over sine A, right? No, other way around. A over sine 18, right? So A equals 13 sine 18 divided by sine 20, yes? 13 works with 20. 18 works with that.
It's 20 over sine 15. 15 is the angle.
Oh, thank you. Now, stop for a second. That A is this yellow number, yes? Over in the yellow triangle, I need the opposite of 31, yes? So sine 31 equals the height I need over the hypotenuse, yes? Isn't the hypotenuse this? It is, isn't it? So sine 31 equals the height I need divided by this, right? Which is sine 20 sine 18 over sine 30, right? Sine 13. Divide by a fraction is the same as what? Multiply by the reciprocal. So sine 31 equals h times sine 13 over 20 sine 18, yes? Right? Multiply both sides by 20 sine 18 to get rid of that. And then divide that by what? Sine 13. And you could do it all in one step. Now listen to me. When you watch like TV shows and movies about math, right? A Beautiful Mind or Good Will Hunting or any whiteboard on the Big Bang Theory, that's what it looks like, yeah? Those math people don't do number. Okay? Why? Not too much time. What do you people do every time your calculator gives you a big long string of numbers? Round it off. And you all round it off wrong. So already rounding it off gets you a bad answer, yes? Not too bad if I'm measuring the distance from me to Joseph, yes? But if I'm measuring the distance from me to the moon and I'm off by 1 millimeter on Earth, how far off am I going to be at the moon? Thousands of kilometers, right? So that's why they try to leave it like this till the very, very end. Then this is where they would do their calculation. Does everybody understand? If you plan on going forward with math or physics or chemistry or engineering or anything that uses this type of stuff, this is how your profs are going to do your notes. You got to be able to get from this to there before you touch a calculator. Okay? Everybody understand? Now, for me, could you go number by number? Yeah, as long as you show me your work, I'm okay. I'll figure it out. I'm not stupid. But I only teach 30 of you. If you go past here, you're going to be in your first year math class. It's probably going to have 200 kids in it. And the prof isn't a teacher. The prof is a mathematician who researches math. He doesn't care about you. Okay? I'm not saying that to be mean. I'm just saying they teach at universities so they have enough money to do research. That's their real job. Okay? So be aware, and also let's be honest. If you can get to there before you touch a calculator, you're going to get a way better answer. Right? Now, if I were to go back to my pre-dip notes from last year and show you, I did a lot of this with you. A lot of moving it around before you touch your calculator. Same thing in measurement, right? Did I ever touch my calculator when I was doing surface area of a cylinder? No, I wrote it all down until I got down to 66 pi. And that's when I touched my calculator. Everybody cool? So all of you should be able to get that answer. And you can punch it in one go. Okay? All right. Do some work. Again, do a couple of these triangles. You don't need to do them all, because if you can do 2 of them, you can do 4 of them. Pay more attention to the word problems. Okay? Go.